Let's compute a couple limits. So the first one, I'll copy paste, is the limit as x tends to negative infinity of x squared minus x cubed, all in parentheses, times the exponential of 2x. So let's see, the negative infinity squared, that's infinity. Negative infinity to the power 3 is negative infinity, but it has a minus. So overall, we have infinity plus infinity. That's infinity. The exponential of negative infinity, that is 0. Okay, so infinity times 0, this is undetermined. But it's not one of the types that L'Hopital covers. Okay, but we can always transform it into something we can handle with L'Hopital. Remember, there are 4 types of indeterminations that L'Hopital can handle: infinity over infinity, negative infinity over negative infinity, and then plus infinity divided by negative infinity divided by plus infinity, and 0 divided by 0. All right, so what I'm going to do here, there are different options, but what I'm going to do is to write the exponential of 2x as 1 over the exponential of negative 2x. Okay? And when I do it this way, then I have infinity divided by, so the exponential of negative 2x as x goes to negative infinity is the exponential of infinity, which is infinity. Okay, so here this is an indetermination, but we can apply L'Hopital. Okay, so we can just take the derivative, 2x minus 3x squared divided by the exponential of negative 2x times negative 2. Let's write it this way. Let's see if that worked. So we have negative infinity minus infinity, that's negative infinity, divided by negative infinity. All right, so still an indetermination, but something that we can handle using L'Hopital. So one more derivative, 2 minus 6x divided by 4 exponential of negative 2x. And when x tends to negative infinity, I get infinity in the numerator and infinity in the denominator. And it's still undetermined, but it's still something that L'Hopital can manage. One more derivative. The numerator gives negative 6, the denominator gives negative 8 exponential of negative 2x. And now when x tends to negative infinity, what is going to happen? The denominator is going to go to infinity. You can also, so this is 0, but if you don't see right away that the denominator is going to infinity, you can also write it like this: 6 over 8 limit as x tends to infinity of the exponential of 2x. And now it's clear, because the exponential of 2x as x goes to negative infinity gives you 0. Okay, so this is an alternative. Now going back to the statement, well, it is actually clear because the exponential, an exponential is always going to beat any polynomial. Okay, so when you see the two together, you already know that the leading term is going to be the exponential. But you need to show it using the way we did, okay? But I'm telling you that so that you can get an idea of what the result is going to be, and also so that you can check that the result you got is, it makes sense. All right, so number 2. Number 2, we have the limit as x tends to 1 from the right of x over x minus 1 minus 1 over logarithm of x. And in this case, as I take the limit of x over x minus 1 as x tends to 1 from the right, what I'm going to get is, because the x in the numerator is positive, and the one in the denominator is also positive, but tending to 0, I'm going to get infinity, and then minus 1 over 0. Okay, that is also going to be infinity. Notice here for the logarithm, we are approaching 0 from the right. So that means that the logarithm of x is going to be positive. Okay, that we need to be a little careful. So infinity minus infinity, which is an indetermination, but not one that we can handle with L'Hopital. So we need to manipulate it until we get something we can work with. Now, typically, when we have a difference of two fractions, the easiest is to actually compute the common denominator. Okay, so x logarithm of x minus x plus 1 divided by x minus 1 logarithm of x. And let's see now. So this is 1 times 0, but approaching from the positive, minus 1 plus 1, that makes 0, divided by 0 from the positive. Yeah, it's 0 divided by 0. This one we can handle with L'Hopital. So is 1 times the logarithm plus x times 1 over x minus 1 divided by the logarithm of x plus x minus 1 times 1 over x. Now, in the numerator, x divided by x is 1, so there is a cancellation. This one here, I'm going to just erase it so that we have less clutter around. And the denominator, I'm going to write it as 1 minus 1 over x, this part here. Okay, so I have 0 divided by 0. Okay, so one more L'Hopital. Limit as x tends to 1 from the right, and then I have 1 over x divided by 1 over x, then the plus 1, nothing, and negative 1 over x, the derivative is plus 1 over x squared. I can, well, you can just go ahead and compute it. I was going to simplify, but there is no need because the numerator is 1 and the denominator is 1 plus 1. So the total is, the value of the limit is 1/2.